One. Hey everyone, welcome to yet another check-in session on the Kubestronaut campaign. So we're about 3 months into the campaign, and we've made a lot of progress. So in today's session, we'll check in on everyone on where they are, and we'll look at some of the progress we've made. We'll congratulate those who have completed their certifications, and we'll also look into some of the recent changes that were made to the Kubernetes exam, and we'll review one or two specific topics from those, some of the mock exams, etc. So let's get started. And let me see who we have. If if you're joining us from wherever you are, please do, drop a comment and let us know where you are coming from. So use the chat session and just say hi and let me know where you're tuning in from. So we'll slowly get started. We'll talk about some of the. I'll start by sharing some of the updates, some of the recent news from the industry, and then as and when we have more people in the stream, we'll slowly get started with the actual sessions. But yeah, I do see a couple of you say hi. So we have Pablo Salvador from Chile. On March 31st, you're planning to give the exam. That's great, awesome stuff. So just right on track. 3 more days left. So all the best, Pablo, for your exams. We have SG, greetings from the USA. We have Michael Pin from Belgium, just achieved my KCNA. Congratulations, awesome job. We have Jose Antonio from Spain. Hello, Jose. We have Chris Su from Canada. We have Mitsev from Macedonia. Gautam from UK. We have Nual El Hila from Morocco. Hemant Reddy from India. Pierre from France. Hello. Welcome to the session. We have Sai Kiran from India. We have Sheikh Azaz Ahmed from India. Gomo from South Africa. Hello. Evelyn from Germany. Aftab from Germany. So yeah, do let us know where you're from. But let me take a moment to congratulate those who have recently completed the certifications. So we have Sachin, who works as a senior team lead DevOps at Mozambique. Is that Mozambique? Who's completed the CKS certification. So a tough one there. So congratulations to Sachin on achieving the certification. We have Nuam, who has recently completed the CKA. So congratulations to Nuam. He's a DevSecOps engineer. We have Hamid Akshal, who's recently completed the CKAD. So congratulations to Hamid. We have Lynn, who is a senior DevOps engineer, who's also recently completed the CKAD. So congratulations to Lynn as well. So we have more folks here from Canada, planning to give a second attempt tomorrow for KCNA. All right, all the best to that. Is there a reason we have CKAD instead of CKA after KCNA? Good question. So it's not a strict rule, but we have two paths, and the path one is where you start with the CKA and then move on to CKAD and KCNA, and then we have path two, which is more for beginner, which is more of a beginner level path, and that starts with the KCNA and then moves on to CKAD, which is considerably an easier exam compared to the CKA. So that's why we started with the KCNA and then the CKAD and then the CKA in an attempt to kind of ease you into the difficulty of the exams. We'll talk more about the paths in a bit. Ankush, we have Ankush, who is from Bangalore, India. Aftab from Germany. We have Mahan Kanchana from Sri Lanka. We have Murad Alam from Italy. We have Alessio Lapi also from Italy. So welcome, guys. Welcome to the to this session. So just a reminder, if you're in the UK, next week we're going to be at London at KubeCon. So as you probably already know, KubeCon is happening from the 1st to 4th of April. The first is a co-located event, so it's not the actual. The actual event starts on the 2nd and goes all the way till the 4th. But on the 1st, we have a co-located event where we have a lot of different sessions on different topics. And one of the things that I'll be hosting is the Cloud Native University. So it's basically a lot of beginner level sessions that happen on that day. And so if you happen to be there, do come by. If you're not there on the 1st, then definitely catch us in our booth. This booth number N513 is near to the project pavilion. So do come and visit us, and I'll be there, and we'll have the rest of the Kodekloud team there. We have swags and everything, so do come by and see and visit us there. Another update. So we have a bunch of hot courses that we have released on Kodekloud the past week. So we have the NGINX for Beginners course. So this is a deep dive into NGINX. It's created by Anthony. So do check it out. It's a beginner level course. So if you've always wanted to learn about NGINX and the deep dive into it with hands-on labs, then this is a really good resource. We also recently released the Certified Backstage Associate. So if you're learning Backstage, if you want to get certified, if you're aiming for the Kubestronaut, the golden Kubestronaut path, then this course will help. And Jeremy also recently released the GitHub Copilot certification. This covers this is a certification course on GitHub Copilot by Microsoft. So definitely check these out when you have time. So going back to the paths, we have the Cohort 1, Path 1. We're at the end of the first quarter. So by now, those who are following the Path 1 in the Cohort 1 should have completed the CKA or should be close to attempting your CKA exams. So I would definitely hope to see a lot of CKA certified associates coming up in the next couple of weeks. So do check it out. We have updated the course. We have updated the mock exams. We've been updating. So there are more updates that has gone into the mock exams the past week. So do definitely check it out. I'll give a sneak peek into some of the mock exams in this session in a bit. But yeah, definitely stay tuned for that. And once we have completed CKA, the next step would be CKAD. And which should be very easy, really. So if you've completed CKA, I would expect you to do CKAD in the couple of weeks from now. So definitely book those exams in. And going forward, you have the KCNA, CKS, and KCSA. The path 2 is more relevant to the answer or the question that a gentleman had raised very recently. Yep. So this particular question. So this is meant to be more on the easier side. So you have the KCNA, which is one of the easiest, probably the easiest exam in all of this. It's more theory focused, concepts focused. So and it's not a hands-on exam; it's a multiple choice exam. So it should be easy for you to crack, and it should be easy for you to gain to help you gain some confidence before you aim for the CKA or CKAD. Comparatively, compared to CKAD and CKA, the CKAD is a lot more easier exam. So that's why it comes right after the KCNA. You can build up your confidence on working through the exam environment and the systems with the CKAD. And then you have the CKA and CKS and KCSAs after that. All right. So here we are with the at the end of the cohort 1, path 1. So by now you should have completed 100% of the course, and you should be practicing your mock exams. Practice as much as you can, and as and when you gain confidence, definitely go ahead and make that first attempt at cracking the CKA. And path 2, again, you should have completed the KCNA by now. If not, you should be at least starting to give the exam. And the CKAD, you should have started your CKAD courses by now. So just note that we have the Notes app that's available at notes.kodekloud.com. So definitely check that out. It's a great resource for you to copy and paste contents from the course. Because we are a video-based course platform, sometimes it can be hard to like copy stuff out of the video, the commands and codes. So, which is why we built this. So definitely check that out. So the exam was updated last month, and so just to walk you through some of the key changes. So the concepts around version upgrades or HCD backup and restore are no longer part of the exam. Instead, we have topics around Helm and Customize and CNI, CSI, CRI, CRDs. So these are some of the new topics that have been added. We have workload autoscaling. So on our last check-in session, we spoke about horizontal autoscalers, and we also worked through a lab on that. There's also topics around pod admission and scheduling, troubleshooting network services, enforcing network policies, and gateway APIs are some of the seemingly new topics that have been added to the exam. All right. And just so you know, our ultimate mock exams have been updated just yesterday. So there are new questions and new topics that are added as part of helping you practice for the new exam. So this includes the latest topics, gateway APIs and autoscalers and everything. So definitely check this out, and I'll also give you a sneak peek into that towards the end of this session. And just and if you're new here, if you're not part of the cohort, we're starting a new cohort starting April. So do sign up for that. If you're already part of the previous cohort, you don't need to do anything. But if this is the first time you're here, then just know that we have a new cohort that's starting in April. So definitely join that. The benefits of joining the cohort is that you get access to a private Discord channel where you can meet others who are going along the same journey. Learn from each other, help each other, celebrate your achievements with each other, and just learn together and grow as a community. So definitely make sure you don't miss that opportunity. All right, and of course you can book your exams if you haven't already by going to the Linux Foundation site. Use the code 20code if you would like to get a 20% off of your exams. Cool. So what we will do today is I thought we could go through the topics around Gateway API, and then we'll also look into some of the mock exams. So let me share my screen here. All right. Okay, so we'll look at an introduction to Gateway API, and then we'll also go through and try our hands on one of the labs. Then after that, we'll look at some of the questions that appear in the mock exams. So that's what we're going to try and do today. So Earlier we spoke about, okay, so this is in the ingress topic that come before this lecture. So we are aware of, I mean, ingress has been part of the exam curriculum for a long time. And prior to this topic in this course, we actually spoke about ingress, and we actually used this example of two services that are hosted on two separate deployments, and how easy it is to use ingress to kind of configure these services. So just as a reminder, I can just give you a quick brief into why we needed ingress in the first place. So without ingress, we had this challenge of services created with different deployments by different teams, and then they have to kind of coordinate so that ingress can help you expose these services outside of your cluster. And when you do that, there are a lot of things that come into play in terms of load balancing, in terms of the header manipulations, in terms of directing which traffic goes into which services and things like that. And in such cases, and then when you're hosted on a cloud environment, there are different layers of complexities that comes in terms of whether you would use a load balancer internally or you would use the cloud load balancer, and how would you configure the cloud load balancer, and where would you configure these settings, where would you configure the load balancing settings and things like that. And then there's also the time to live, the TTL values, and course settings and all of that. And that's what ingress helped solve, right? So what ingress did is it deployed an NGINX server internally, and then with a set of Kubernetes resources, it helped you configure that NGINX server for these different services. And it provided a single endpoint outside of the cluster that users can hit, and then all the routing and everything was done by this NGINX, which acted as that ingress controller and ingress as a set of ingress services. But so that solved a lot of problems, but it also kind of created a bunch of others, right? And that's what we're going to look at in this session. So one of the challenges with ingress was that if these services were deployed by different teams, like for example the wear service in this case, the clothing store or whatever we used as an example in our case study, if that was owned and managed by one team, and if we had the watch service, which is another service that was owned and managed by another team, so you had two different teams working on two different services, but eventually they wanted to use the same kind of ingress. What happens is that this results in them like kind of stepping on each other's toes, right? So now they have to work on the same kind of configuration file, the same kind of ingress controller. So there's a single ingress controller, and both of these teams need to work hand in hand to be able to configure this ingress resource. So that was one of the challenge. So there was no built-in or native support for multi-tenancy. There was no support for namespace isolation, no RBAC features really. So there's no resource isolation happening. So that was one of the major challenge. The second one is the ability to configure ingress, right? So natively, or whatever you specify within the under the specs section is what is really understood by Kubernetes, and that is what you can like run queries on or run configurations on. That's what's really tracked by Kubernetes. Everything that comes under the specs section of a resource. So in this case, we're saying this particular host. So whenever a user types in where.myonlinestore.com and that traffic hits the load balancer, if the host name that user typed is where.myonlinestore.com, then we want to redirect that traffic to this particular backend, which is the where service, right? So that is one set of one configuration. So you can, based on the host name that the user typed in, you can redirect traffic to a particular service in the backend. And if the second rule is the watch, the second rule is similar rule is the watch, right? So if the user typed in watch.myonlinestore.com, then you want to direct that traffic to another service. So that's called as host matching. So you basically redirect traffic with the name of the host that's configured in the rule. So that was one thing that was supported. The second is path matching. So you can match a traffic by the path. So if the user typed in myonlinestore.com/where or /watch or something, then based on that path, you can configure or you can route the traffic, right? So that's path matching. And this only supported HTTP kind of routing only. There was no, TCP or other layers of configurations that was possible. Even though the underlying controller supported that, the specs that are specified here did not support those advanced kind of configurations. So those were some of the challenges with Ingress. So there was no native support for TCP or UDP routing. There was no support for traffic splitting. There was no support for header manipulation, authentication, rate limiting, redirects, rewriting, middleware, or WebSocket, or CORS, or session affinity. So there was no support for any of this in the native Ingress resource. And what I mean by that is you could not specify these configurations under the spec section of Ingress resource, right? That's what ultimately that means. But you could still configure those by working around the limitations of Ingress. And the way that was done is by passing some of these configurations through what we call as these annotations, right? So the way annotations work in Kubernetes, so on any resource, you could kind of give any annotation. So under the annotation section, you can specify any key value property, which would then be passed on as metadata, just as is, to the underlying controller. So Kubernetes has nothing to do with whatever is specified here, right? It is unaware of what these properties are. All that Kubernetes does is it just takes these annotations and it just passes these as is to the underlying controller. So in this case, you can see examples of SSL redirect or force SSL redirect, and some of these, properties that were set to true, which are usually passed as is to the underlying controller. So so some of the examples are, and these are different between different controllers, right? So NGINX has the annotations for some of these, like enable CORS or CORS configuration as specified here, and then you can see a completely different approach to how it would be configured by another controller like traffic. So each controller have different types of annotations. So there's no like consistency, right? So if for some reason in the future, so let's say you started with NGINX, you have all of these configurations defined through annotations, and in the future you decided that we're gonna move from NGINX to traffic or some other solution, then you'll have to go through all of these resource files and start reconfiguring this and testing it and making sure it works, right? So there is no, and that is mainly because there was no native support for these configurations in the Ingress API. So these were some of the challenges with Ingress, and that's what the Gateway API resolves. So Gateway API is the official Kubernetes project, and it's focused on layer 4 and layer 7 routing. So this is the next generation of Ingress, the next generation of load balancing. You can think of it as the next generation of service mesh APIs. So we spoke about the limitations with not supporting multi-tenancy, right? Different teams handling different resources. So we'll see how Gateway API resolves this. So with Gateway API, you have Gateway class, which is at the top level. So this is what defines what is that underlying Ingress controller. And this is configured by the infrastructure providers, right? So now we have different layers of people. We have different roles that are that are responsible for configuring different parts of the this whole gateway solution. So we have infrastructure providers that define what the gateway class is, and then we have cluster operators. So these are the sysadmins, the Kubernetes administrators. They configure the gateway itself. So they configure the gateway resource, which is a an object of that gateway class that was defined by infrastructure providers. So in this case, the infrastructure providers would say, here we have, we give you NGINX or traffic or these particular solutions. This is what you should be using. And the cluster operators would then create instances of those called gateway. And then the actual configuration of those Ingress resources would then be done by application developers, right? So in this example, it's the application developers who would then own configuring these rules to say, this traffic has to hit this particular service in the backend, or all of those are configured by these application developers. So HTTP route is just one example. As I mentioned, with Gateway API, we now have many more configurations available. So you have TCP route, you have gRPC route, and many others, right? And we'll take a look at that in a minute. So before we look into that, let's just look at what each of these mean, right? So the gateway class is defined by a resource like this, the API version, kind, and metadata and spec. So the kind is gateway class. A name is any name you give it. And then you have the controller. So you still need that controller, that we spoke about exactly how it worked in the Ingress space, where you install NGINX as a controller. You first install a controller, and that could be anything. And then you create a gateway class, which is what specifies, which is what links that controller to this whole API resource, right? And then you have the gateway itself. So the gateway is created from that gateway class name. So in this case, we have the example class, and this gateway object is created from that example class. And then you have the listeners configured at this level. So this is what defines like what traffic is then going to be listened from for that particular gateway class. And then you have all of the route configurations. So you have HTTP route. So you have a separate resource for each route. So in this case, this is an example of an HTTP route. And as you can see, the parent ref is the example gateway. So that's how the route is linked to the gateway object that we created in the previous step. And this is where you specify, what are the host names and what are the rules and what are the things that you want to match, and what traffic is going to which target, which destination. That is referenced by the backend refs that you can see configured in that in the routing route configuration. So let's look at as I mentioned, along with HTTP route, you have the TLS route, you have the TCP route, UDP route, gRPC route, and many others that we will look into through the documentation in a bit. So let's just compare how things work in the Ingress and the gateway world, right? So in the Ingress world, we had the SSL redirect and SSL, the four SSL redirects configured as annotations. But here, as you can see, you have it as part of the spec itself. So this means that now Kubernetes is aware of these configurations, right? And this works the same way. These configurations remain to work the same way across all the different controllers. So now you no longer have different annotations for different controllers. This kind of works the same way across all controllers, and it's kind of generalized now. Here's another example of the canary configuration. So in NGINX, again, you had canary defined in the annotations. There's nothing in the spec sections, but now with the HTTP route resource in the gateway API, you now have rules, and in these rules you have the canary deployments specify that 80% of it is going to V1 version of the app, and 20% of the traffic is going to go to the V2 version of the app. And this is another example for the course configuration. Again, as you can see, the course configurations were in the annotation section for Ingress, and now with Gateway API, you have everything defined inside the spec section, and under filters, you have all of these cross-origin the controls around those specified as specified here. So a lot of the very popular controllers have now implemented gateway. So that means they'll support gateway configuration. So what's happening here is now Kubernetes has this new resource called the gateway and gateway class and all the different route configurations. And for these underlying controllers like NGINX or traffic or others to work with this configuration, they need to build some kind of adapter. They need to there are some modifications that they need. So they need to provide some kind of a controller that works with the gateway. So there's that expectation from these controllers that they need to build and make themselves adaptable to the gateway resources. So as you can see, a lot of the popular controllers like HA Proxy and Istio and Kong Gateway and Kuma and Traffic and others have already kind of built support for the Gateway API, and they're in GA, right? So they're generally available. So that's a great step towards implementing Gateway APIs. So let us now look at some of the documentation. I think this is very important before you start working on the labs or anything. So first, if you go to Kubernetes documentation pages, search for Gateway API, you get this link, and here you can see the different resources or documentation that's available. So note that within the Kubernetes documentation pages, you don't have very extensive documentation on the Gateway API, right? So Gateway API has its own kind of documentation pages, which I think if you click on this link right here, it will take you to this site called as gateway-api.6.kh.io, and this is where you have very extensive documentation around this. And I would assume that because this is a Linux Foundation project, CNCF project, I would assume that this is also available and accessible during the exam. So this should be accessible. So you shouldn't have to worry about access. So if you have a question on Gateway API during the exam, then you should be able to go here and access the documentation pages. So first of all, this is where it speaks about the different roles or personas that are available. So you have the infrastructure providers working on the gateway class, and then the cluster operators are working on gateway, and then you have application developers that are working on all the different configurations, HTTP route, TLS route, and all of that. So how do we know which one is what? So if you go to the API overview section of the documentation page, so here are some really good examples. So I would highly recommend you to go over and read some of those. But if you see, you have some of these specifications here on what are the different APIs that are available within Gateway, right? So you have the HTTP route, and you can read what it is about. So HTTP or terminated HTTPS connections, TLS route. You have the TCP route and UDP route. You have the gRPC route. A brief description of what each of those are, and how you can attach routes to gateways. There's some information about that. So when a route attaches to a gateway, it represents configuration that is applied on the gateway that configures the underlying load balancer or proxy. So you have a one-to-one and one-to-many and many-to-one configuration. So a gateway and route may be deployed and used by a single owner and have a one-to-one relationship, or you can have a gateway with many routes bound to it that are owned by different teams across from different namespaces, or you can have routes bound to more than one gateway, allowing a single route to control application exposures simultaneously across different IPs. Yeah, so there are some examples here. So there's the infra namespace, which has the gateway API configured, and then you have different namespaces using that same gateway, right? So that's one option, or you can have a dedicated gateway within each route. All right. Just checking in on the questions here. I'll update. I'll take on the questions about, the generic questions in a bit. Just seeing if there are any questions specifically about this topic. No, so I'll just keep going. So there are some examples here in terms of how you create HTTP route, the different route configurations. So every route has a link, a reference to the parent gateway, which is specified here with the parent refs property, and then you have the kind specified to gateway. The name is the name of the gateway, which is full gateway here, and then the rules are in the rules you have the references, and yeah, this is something we spoke about. So I'm trying to find the specific details about each resource. So if you go back here, and if you just search for HTTP route, you have the HTTP route configuration here. So if you click on any of this, it should take you directly to that route specification. Yeah. So in the exam, this is where you can find some references and reference codes. So if you need to know like how a particular rule is created, and what are the different values that can be configured, header configuration. So this is one place that you can go to for reference. All right. Yeah, okay, so this is what I was looking for specifically. So you have, if you go to the documentation pages, you have the API specification, and under that, if you click on standard, you get to this page, and this is where you have like the exact details about what each of these really mean, right? So for example, under the resource types in Gateway, we have these different resources. And if you need to know what each of these mean, that there are properties that go under each of those resources, then you can read about them here. Like for example, absolute URI, address type, allowed listeners. So allowed listeners defines which listener sets can be attached to this gateway. So there are like namespaces. So how do you configure namespaces that you can attach to this gateway? So then you have allowed routes. So allowed routes define which routes may be attached to this listener. So you have route namespaces. So these are the namespaces, indicates the namespaces from which routes may be attached to this listener. So there are some of these configurations that you should read through and get yourself familiar with. What we can do now is just quickly go through one of the labs. And look at, just get a hands-on experience of whatever we just spoke about. So this lab is part of the course. So right after the lecture on Gateway API, you have this lab. All right. So the question here is, let's start with this. There are about 8 questions in a very basic question. So which API resource is used to define gateway in Kubernetes? So you have route, gateway class, and ingress class. Definitely not ingress class, definitely not routes. So is it gateway or gateway class? So to define a gateway, it's just gateway, right? So we'll just go ahead with that. Now, what is the purpose of the allowed routes field in a gateway? So this is where it would be good to refer to the documentation pages to understand what it means. So if you go here, back to this documentation page, there are some details here that would be good for you to like refer to while working on the labs. So the question is allowed routes. So what are the allowed routes define? So allowed routes defines which routes may be attached to this listener. So there's like namespaces and kinds. So you could say, you can define like an entire kind to be the allowed routes, right? So, or you can say namespaces. So this indicates the namespaces from which routes may be attached to this listener. So going back to this, you say specify which namespaces can be attached, can attach routes to this gateway. To limit the number of routes, define the traffic rules, to enable multiple gateways to share the same listener. So in this case, the answer is the allowed routes are used to specify which namespaces can be configured to listen to this listener. So the next question is, which of the following protocols is not supported by Kubernetes Gateway API? So we know HTTP, TCP, HTTPS are configured. ICMP, I guess that's the one that's not. And that's not part of the resource types that we have seen. Next is, how does a gateway class differ from gateway? So a gateway, as we discussed, gateway is the higher level object, and then it's from the gateway. Sorry, the gateway class is the higher level object. That's what defines what a controller, that's what ties a specific controller to a gateway class. And then a gateway is created from those classes, right? Like multiple gateways can be created from those gateway class. So gateway class is created dynamically when a gateway is created. Don't think that's true. The gateway class defines how a gateway is implemented by a controller. Gateway and gateway class are interchangeable. Not true. And a gateway class must exist inside the same namespace as a gateway. No. So I think so. A gateway class defines how a gateway is implemented, right? So gateway class is what defines what that controller is that all the gateways that are created from that gateway class are going to be using. Next, we have, what is the primary advantage of using Gateway API over Ingress? Easier to configure, supports more advanced routing and multi-protocol support, replaces network policy, does not require a controller. So it does require a controller. So important to note that. Easier to configure, well, it streamlines a lot of configurations. So in a sense, it is easier. But out of this, the most relevant answer is that it supports more advanced routing and multi-protocol support. All right, so next up, we're going to set up the gateway controller. So to use the Gateway API, a controller is required. And in this lab, we will install NGINX Gateway Fabric as the controller. And the first step is to follow and install the NGINX Gateway Fabric. So what I mentioned earlier about how the controllers, so NGINX or Traffic or whatever the controller is, they need to build something that could work with Gateway APIs, right? So in this case, it's the NGINX Gateway Fabric. So the first step is to sorry, I think I made a mistake. Yeah. So the first step is to apply this configuration to deploy the NGINX Gateway Fabric to our cluster. So this is what kind of enables NGINX. This is what has the NGINX controller, and enables NGINX to work with gateway. So in the first step, we just created the API resources. In the next step, we're going to deploy the Gateway Fabric CRDs, or the custom resource definitions. So now we have some of these custom resource definitions created on Kubernetes, and then the next step is to deploy the gateway itself. So this is where all the deployments and the namespaces are created to deploy the NGINX Gateway Fabric. So what we can do is see what all resources are created. So we have the NGINX Gateway namespace that's created. So if you do get namespace, we have we'll see a new namespace that was created, which is called NGINX Gateway. And within that, we have a service account created. We have a cluster role and cluster role binding named NGINX Gateway that's created. We have a config map that's created, and then we should have the NGINX Gateway, which is a service. So if you do get service, you should be able to see. Let's try and make that bigger. You should be able to see the NGINX Gateway service deployed in the NGINX Gateway namespace. And it has a node port, and the node port is set to 32115 and 31290. So 32115 for port 80 and 31290 for port 443. Let's take a look at the pods deployed in the NGINX Gateway namespace. So we have the NGINX Gateway pods, and they're both in a running state. So next, we're going to verify. We have verified the deployment. We're going to view the NGINX Gateway service. Okay, so we have now successfully deployed the gateway. Right, so the next step is to create a Kubernetes Gateway resource with the following specifications. So first, I need to find an HTTP route sample code for deploying that. So we'll go here. Go to the API overview. All right, so we have this HTTP route configurations. So we'll copy that. All right, so the name is NGINX Gateway. Namespace is NGINX Gateway again. So and then we have the parent refs. So the gateway class name is NGINX. And I think this should also be NGINX Gateway. And then we have the rules and allowed routes. So let's go here and identify how allowed routes are configured. So here we have the allowed routes specified. So yeah, so this is a better spec that we can use. It should have name, port, protocol, allowed routes. All right, so I'm just going to copy this section. Show this tab. Actually, this is not what I need. Okay, I needed that. All right, so we have the spec. So the gateway class name here is NGINX, and we have listeners. The name is HTTP, port is 80, protocol is HTTP, and then you have allowed routes, and we just need to specify all namespaces. So under namespaces, we have from, and this here we could just say all. Right, and that should basically do it. So we'll say kubectl apply dash app NGINX gateway. Okay, so we have a gateway class name. There's something wrong. Namespace, what's wrong here? Oh, we're creating a gateway resource, sorry. Copied the wrong one. What's wrong here? So we have gateway.networking.ks.io. The kind is gateway. We have the name NGINX gateway. We have the namespace NGINX gateway. What do we have wrong here? Unsupported value all. Okay. Well, yep. It should be all with a capital A. That's a good one. Good learning. Okay, so that was the issue. So, yep, caps letter cases matter. So we'll do a get kubectl get gateway. And yep, so we have the NGINX gateway created. All right. So yes, I see we have, yeah, thank you. Thank you for that, pointing that out. Okay, so we have a new pod named front-end app and a service called front-end service being deployed in the default namespace. So let's take a look at that. So qcat svc. So we have the front-end service, and we have the pod, which is the front-end app pod. And it's been deployed in the default namespace. Expose the service on the slash path by utilizing an HTTP route named front-end route. Okay, so now let's make sure we copy the right code. So now we can copy the HTTP route code. So we'll create HTTP route.yaml. So the route name needs to be front-end route. We have the namespace, and the namespace is default because our services are deployed in the default namespace. The parent ref is the gateway that we created in the previous step. So I think that was NGINX gateway. And the namespace was also NGINX gateway. So put it there. And let's go and look at some of the rules that are available. So what we want to do is we want to match the path slash, right? And we want to point that to the backend, which is the front end, the front end service. So we have the type, which should be a path reference. Right, so let's look at reference. Let's look at the API standard, HTTP route, HTTP route spec. So we have parent spec. That's not what we want. We have a host name. And then we have rules. So what we want is should be inside rules. Try and zoom in here. And then we have rules, and we have HTTP route match, HTTP route filter, backend ref, and what we really need is matches. And this is basically what we're looking for, right? So what we need to match is the path slash with the path prefix. Okay. All right, so we have the path, and the value for the path is slash, and then the service is front end app. Oops. And the port is 80. This should be an array. That work. So not the best looking, but let's give it a shot. So there is an error. Let's look at the solution. So we have the rules, and under rules we have matches. We have matches, and then we have the path specification, which is an array, and then we have the value, and then we have the path prefix, which is the type. And the path, the backend refs are another property of that. So we have the rules, which is an array, which is matches. So you can have multiple matches, and within the matches, there are multiple paths that you can match, and matches and backend refs are, so matches and backend refs are the same property of a rule. So anything that matches the paths that you have specified, that is directed to the backend that we have configured here, in this case, which is the front-end app. All right, so let's do a get HTTP route, and we get that front-end rule that was created. All right, so it says, is the service exposed to the outside world? It's going to take, I guess, a little bit for the configuration to go through. But meanwhile, let's compare this. So you have the front end route. Okay, the backend route is SVC, correct. Thank you for pointing that out. So it's SVC, not a front end app. The rest of it is good, I guess. Right, so we apply it again. Okay, that works. Awesome. And if you go to the link, then you can see the app is now exposed. So you can do that by clicking on the gateway here. Cool. All right then. So yeah, I think we're at the end of our session. I hope that was helpful. Yeah, thank you for pointing that out again, Sagar and Komodemo. Appreciate your support. So yeah, this has been a great session. Thank you so much, guys, for your support. We'll be back in 2 weeks from now, and hopefully I'll get you some more mock exams or sample exams and sample questions, and we can go through that. Maybe we can go through that together. So if you guys are interested, definitely come back and check in 2 weeks from now. Until then, do stay connected. Thank you so much for your time, and I'll see you 2 weeks from now then. Well, thank you.